So hello friends. So in part 1, track quality part 1, we have seen basic terms like what is SD. SD means what? Standard deviation, and how to calculate SD. Okay, we have seen what is nominal gauge, what is mean gauge, what is vertical and lateral acceleration. So continuation to part 1. In part 2, we'll see data collection. So to calculate SD, we require data, right? So for that, in part 2, we'll understand at what lengths we'll collect the data and how many data points we'll take. So these two things we'll understand today, right? So what length means, whether, so let us take at every 1 meter we have to take the data, or every 2 meters you have to take, or every 1 mm we have to take the data. So at what length you have to take the data, that we'll understand, and how many data points we'll take, 200, 300, how many data points we'll collect to understand SD. So that's what we'll see. So to understand what length, okay, so at what length you have to take the data, for that you have a concept called chord length, right? So you have a concept called chord length. So for understanding unevenness, we have two chords, short length chord and long chord. Okay, short chord at short, okay, it is 9 meters, long chord is 18 meters, right? And for alignment, you have short chord length of 9 meters and alignment, uh, okay, long chord is 15 meters. For twist, 3 meters and 15 meters. So to understand this length, where we will measure unevenness, alignment and twist, okay, before that we have to understand curves. So where you have a chord length of 20 meter and, okay, station at every 10 meters. Points and crossing, you have a chord length of 6 meters and station at every 3 meter. So before, after understanding this, we'll go through this, okay, unevenness. So for curve, so let us say you have a curve like this. So this is station 0, station 1, station 2, station 3. So in curves you have stations at every 10 meters like this, okay. So if we want data at 1, what we'll do, we'll fix a chord like this and we'll measure data here, okay. Chord length was what, 20 meters. So first reading you got like this. Next, for getting reading at station number 2, what we'll do, we'll fix a chord like this connecting station 1 and 3 whose length is 20 meters, and we'll note down the data here, okay. So in curves we use a chord of 20 meters and we'll take reading at center, that is at 10 meters, right? So similar way, for unevenness, what we'll do, so for unevenness, so let us say you have a track like this, okay, you have a track like this. So for unevenness, short chord is 9 meters, right? So what we'll do, let us say this is 0 station, this is station number 1, station number 2, station number 3. So 4.5 meter, 4.5 meter will mark the stations. Right, now we'll fix a chord like this, right, of length how much, 9 meter, and at center we'll measure the reading for unevenness, okay. Next, second reading how we will take, so you will fix a chord like this, just like in curve what we have done, whose length is 9 meter, and at center we'll take the reading of unevenness. So this is how we'll take for short chord un1, right? For un2, how you will do, long chord 18 meters, right? So let us say this is our track, right? So let us say this is 0 station, this is station number 1, station number 2, station number 3, right? So this is 9 meter, 9 meter, 9 meter, like this will mark the station. Now first reading how you will take, you will fix a chord like this, okay, between station 0 and 2, at center you will take the reading number 1. Next, how will you take reading number 2, okay. So you fix a chord connecting station number 1 and 3, and at center you measure the long chord unevenness. So like this you have to measure the data based on this chord lengths un1, un2, al1, al2. So based on their chord lengths 9 meter or 18 meter, 9 meter or 15 meter, so based on these chords, okay, you should not measure wherever you want, so you should measure the data point at these locations by using short chord and long chord. Okay, so I hope this is clear. Now manual data collection is very difficult, so at present we are collecting data by using TRC, track recording car. So it will collect all the data like unevenness data, alignment data, right? All this data was collected by TRC. So you have unevenness, so you can see here unevenness, alignment, gauge, right, peaks, acceleration, all this data was taken by TRC or entire length. Now how TRC records the data, this is very important, and based on this data of TRC we are calculating TQI, right? Understood or not? So how TRC will record the data? So what TRC will do, entire stretch, entire kilometer was divided into small stretch of length 200 meters. So this is block number 1, block number 1, block number 2, block number 3, 4, 5. So in 1 kilometer you have 5 blocks whose length, each block length is 200 meters. In this 200 meters length, all the parameter UN1, UN2, AL1, AL2, okay, peaks, gauge, all this data was recorded in this length. Now in each block, at what length it will record, that we will see again. So see, now I have taken one block, let us say this is block number 1. So how it will record data, at what distance it will record data in block number 1. So for this let us understand for unevenness. So what it will do, so first let us say this is 0, okay. Now from here 25 centimeters, next from here this is 1, this is 2, this is 3, this is 4, okay, this is 5. So 25 centimeters, 25 centimeters, 25 centimeter, 25 centimeter, it will divide like this. Now what it will do from here, so let me take another color. So from here what it will do, so for unevenness 9 meter, right? So from first to 9 meters, okay, at center of this how much, okay, 9 meters, center is how much, 4 and half, 4 and half. So it will record the data at center. So let us say this is data number 1, okay. Now next what it will do, it will move to next to 25 centimeter. From here it will take how much, 9 meters, and at center, so this is data number 2, right? Next to 25 centimeters, so what it will do, from here it will fix 9 meters and record data number 3. So like that it keep on recording. So what was happening here, every 25 centimeters it is recording the data, 25 centimeter it is taking the data, 25 centimeter taking the data, okay, every 25 centimeter it is getting the data. So like that over 200 meters length, and each data point was at 25 centimeter, means 0.25 meter, right? 200 divided by 0.25 means 800 readings. So for UN1 you are getting 800 readings, for UN2 you are getting 800 readings. So like that for all data, AL1 800 readings, AL2 800 readings, like that it is taking the reading. So I have shown in picture here, see here. So first 9 meters it will record at center, next it will move by 25 centimeter, and again it will record the data at center, okay, again it will move by 25 centimeters from here, and it will record the data here. Next again it will move by 25 centimeter and record the data at center of chord 9 meters, again it will move by 25 centimeter, record the data, like that. So this way it will record the data. So same way for alignment, how it will record. So for alignment you have short chord of how much, 9 meters. So in a block of 200 meters, so 25 centimeters, it will get one data, again 25 centimeters, and fix the chord of 9 meters at center, it will record the data, again move by 25 centimeters and fix the chord of 9 meters, it will record the data, and keep on recording like this. So this will be recorded for alignment, unevenness, gauge, and etc. all this, right? So similar way, for peaks, so, right, so all those will be recorded. So overall what we understood today, right? So chord length basis track parameters were measured. On chord length basis 9 meter, 18 meter, like this, for unevenness, alignment, twist. On chord length basis you are recording the data, you are not recording wherever you want. You should record, you should measure the track parameter based on chord length basis. That is one thing. Next, TRC records data in each block of length 200 meters and at every 25 centimeters. So like this you are recording data using TRC at every 25 centimeters in a block of 200 meters, and in each block you are getting approximately how much, 16,000 readings, right? Next, for each block SD values of track parameters of, so for this you are getting 800 data points, and for this you are calculating what, SD values. Okay, similarly for this you are getting 800 data points, you are calculating SD. So this is called UN1 SD, UN2 SD. So like that you will record the data. I hope this is clear to you, right? So in last video we have seen some basic things like what is SD, how to calculate, and this part you have seen how to collect the data at field. Okay, so TRC and chord length basis, so these things you have seen, and we go further in next class. Thank you friends.